Okay, our final video for Unit 7. Okay, let's think about all the techniques we've used for integration and how can we apply them. Okay. Looking at question 1, this one right here, which of the following, 1, 2, or 3, are equivalent to this integral from 0 to 5 right here? Okay, so we basically just need to take this thing and do a bunch of stuff with it to see if this stuff is true. Well, first off, do we have an integral property around division? If you go back to our integration as antiderivatives, did I give you any rule that says we can split an integral and say that the integral is of a polynomial, or I'm sorry, this is a rational function. The integral of a rational function is equal to the integral of the numerator and the integral of the denominator? No, I've never said anything like that, and that's because that is just simply not true. We cannot just take the integral of the numerator and the integral of the denominator and that gives us something. That is not a rule, so I already know that this one is wrong. Okay, and the other two we're going to have to do a little bit of work for. So this first one, well, how did they get here? We have a rational function and it ended up being something plus something else. This looks to me like the product of long division. So let's use long division and see what happens. So we're doing x plus 2, 3x plus 11 divided by x plus 2. You can pause the video now. I'm not going to show the work for this. I'm literally just going to go to the answer. I did another video on long division. But you should get that it's going to give you 3 plus 5 over x plus 2. And so that means that we get the integral from 0 to 5 of 3 plus 5 over x plus 2 dx. And boom, that's this one right here. If we use long division, it gives us that. So this one is true. This one is good. And now our third one, well, if we're still thinking about how can we find the integral of this, or what this looks like, well, this looks like a u sub, so let's do u substitution. And again, I'm not going to go through the work on how I did it, but you can pause the video now and you can see. And when I come back, I'll have what this integral is. Okay, and coming back, when you do your u substitution and you change the bounds of integration, remember when I said there's going to be questions you need to change the bounds of integration, this is one of them. We change the bounds of integration and we get that, and boom. So which of the following are equivalent? Well, 2 and 3 are both equivalent to this integral up here. Okay. Moving along, I'm going to come to this one. Same question, which of the following is equivalent? So what we're going to do is I'm just going to take this integral and I'm going to do stuff to it. And I'm just going to keep in mind everything I've done to it until we see something. And this integral looks complicated. But it's really not that tricky. Let me zoom out. I'll let you try and solve it on your own and then I'll talk, but I'm going to talk very quickly through this one. Okay, so what do we do here? Well, don't get confused. Don't get caught up in all the nonsense. We've learned U substitution. We've learned completing the square. We've learned long division. But don't get caught up when we see something like this, which is something we should know really intuitively how to work with. This is just going to be, and you actually could use long division here. But you don't need to. And if you don't need to do something, work smarter, not harder. Let's just take the denominator and divide all of our terms by the denominator. What is x to the 7th divided by x squared? Well, that's x to the 5th. What is 4x cubed divided by x squared? Well, that's 4x minus 4x. What is the 6 divided by x squared? Well, that's plus 6x to the negative 2. And boom. Oh, I forgot something. You should be yelling at me. I forgot my dx's. This would be our first step in sort of doing this problem. And let's see, if we look, we can see answer choice C actually does this already. Because there's nothing else to do after this. After this, you're just integrating. You're just integrating this. So there are no more equivalent integrals. So our answer is just C. Boom. Okay. Coming back here, we'll scroll down. Which of the following expressions are equivalent? Again, we have 3 options. And again, well, take a second, pause the video, figure out what we should be doing. Okay, so hopefully you immediately crossed off answer the first one, because I was very clear that we cannot just take the integral of the numerator and denominator. And then it's a similar process. We're going to end up using long division. I'm not going to show the work for it, but it should give us this. When you do your long division, it should get you to this one. That is the same as that. And then again, you can do your U substitution. This one's actually a little trickier, so I actually think I'm going to show a little bit more work here. When we do our U substitution, we end up with this. But you end up with a negative out there. I'm not going to show the work for how I got there. But what I am going to show is the bounds of integration and what happens with that. Well, if I substitute a 1, we used 5 minus x as our u. So if I substitute a 1 in, 5 minus 1 is 4. So this is going to be 4. Hold on one second. Sorry, I got tripped up. This integral here is from 2 to 4, not from 1 to 3. I don't know why I ended up putting that there, getting ahead of myself. If I substitute in a 2, 5 minus 2 is 3. If I substitute in a 4, 5 minus 4 is 1. So we end up with this. this integral right here. And this does not look exactly like that, but remember, our bounds are messed up right now. We're going from 3 to 1, and we want a lower bound to a higher bound. This is a higher bound to a lower bound. So we need to flip it, and when we flip it using our integral rules, we multiply by a -1, so this negative is just going to end up going away. So we end up with the integral from 1 to 3 of -2 plus 15 over u du. And this is the same thing as that. It's just putting the 15 over u in the front. It makes no difference. Same idea. So we get that 2 and 3 are both equivalent. Boom. Last question. This one here. Okay. Let's just try and integrate this and see what methods we would do to try and integrate this. Looking at it, taking the derivative of this is not going to help us, so I don't want to u sub here. Taking the derivative of this is not going to help us, so I don't want to u sub there. Let's try just distributing. Let's just distribute this. Just like how before, all we did was we basically distributed the denominator. Let's distribute this and see what happens. Let's see how good we are with multiplying our exponents. So this is, we distribute it, it's going to give us the integral of 9. The square root of x times x cubed, that's 1/2 plus 6 over 2, that's 7 over 2, so 9x to the 7 over 2. And then square root of x times -2 square root of x, that's just going to be -2x. Plus, and then we have the square root of x times 8 over root x. That would be plus 8 over root x dx. Does that match anything that we have? No, but it looks pretty close. Sorry, I got sidetracked. My brain wandered for a second. It looks pretty close to this one. If we look here, this dividing by the square root of x, that's the same thing as, I'm just going to rewrite it. I'm not going to write the whole line out again. 8x to the -1/2. If I write it as a rational number instead of a root. And boom, this is the same thing as that, and we get our answers B. The only other thing I want to say about this question, which I didn't do anything on the first one, but in the same way that division, you can't just divide integrals, you cannot multiply integrals either. That's not a property of integrals, and I could easily prove that to be false. But I'm just going to leave it at that. I'm just going to have you trust me that we cannot just multiply these two things, the integral of these two things, and get our function. Okay. And this is my last video on this unit. You now should be able to integrate pretty much everything, and we'll spend days in class practicing and going over this stuff, but all the videos are done for this unit.